Hello, so let's look at electric circuits and understand what's actually going on there. Okay, now we have got two these are circuits that we are having here, and we're having a battery here, and what we have here are what you call the resistors. So we've got the resistors here, which are your bulbs in this case, and they're active. So let's try to understand some of the terms that we see here. Now, we are using what you call current. What is it current? Let's keep it simple for everyone. This is just the flow of your electrons. Okay, flow of your electrons. Now, what about potential difference? We are saying this is the energy used to move your electrons. Let's keep it this simple for us to understand. Resistance. This measure the opposition to the flow of electrons. So it's measuring the opposition to the flow. Because when I talk about resistance, it's resisting the movement of electrons that we are talking about here. Okay, so now let's again now talk these resistors, or the relationship between the three here is that we can use a triangle to remember. So we have got V, so we've got V there, then we have got I, which is our current, then we have got our R, meaning to say if you want to find a V, you say I times R, which is current times resistance. If you want current, it's going to be V over R, and if you want resistance, you say V over I. Okay, now let's now again understand how these resistors differ. So we can see we have a series connection and we have a parallel connection. Now, when we have a series connection, we refer to it. So let's talk of series here. We refer to it as a potential difference. Potential difference divider. So potential difference divider, meaning to say the potential difference here and the potential difference here are different. So we can say this one V1, when this one we can call it V2. So these two are different. But what about the current that we have in the the current? Our current here will be the same. Current here we can just let's use current at this point here is the same as current at this point here. So we can say current here, and also is the same as the current here. So we can say current 1, current 2, current 3, they are the same. Okay. But here V total, you get it by saying V1 plus V2. That's how you get your your potential difference for series connection. But what about current? Current total is equals to your current 1, your current 2, your current 3, because it remains the same throughout in our resistor. Let's just say the resistance here, let's say resistance here is 3 ohms. Okay, then this one here is 4 ohms. Okay, now when we have got these 3 and 4, we can calculate the total resistance, which you can say R total in this case, or R series. Okay, showing that is gonna be equals to R1 plus R2, which in this case is equals to 3 plus 4, and we get 7 ohms. Okay, let me take you also to the other side of parallel connection. Now, when the parallel connection, we can see what we have here. This is what called a switch. So you can see the one bulb is on top of the other. And what happens with our current? Our current, when it's moving here, we have got current total in this side here. When it gets here, it's split. when it gets here, it's split. So we've got current 1 going via what call the first what call the resistor, the first bound, and we have the other current actually what call going to the other bound. So now, if we are saying it's going to be split, it means that this is parallel connection is current divider. Parallel connection is what you call a current divider. Now, when it's current divider, it means that current total is equals to current 1 plus current 2. Okay, then we have it what we're going there. But what happens here if I'm to add another bulb here? Let me just add another bulb. I will show you why I'm putting this bulb. Okay, now if it happens that we open the switch, we will be left with what you call series connection. So opening the switch will leave us with a series what you call connection. But if we close the switch, it will leave us with a parallel connection. Okay, so always remember that open switch, open switch, it means that it's what you call series. Then when we close, it means that we are having what you call parallel what you call connection. Now, let's now see how do we get how do we get the resistance here. Let's keep the same thing here, 3 ohms, then also 4 ohms here. Now, what about R total here? In this case, we say RP, 1 over RP is equals to 1 over R1 plus 1 over R2. Okay, in this case, we're going to say 1 over RP is equals to 1 over R3 plus 1 over what we call 4. And what do we get there? If we calculate that, we're going to say, okay, 1 over 3 plus 1 over 4, which is a quarter, we get 7 over 12. 7 over 12, that's 1 over RP. Now, what you do here to get the RP, you just what you call get the reciprocal there, which is upside. You just switch the values here, denominator and numerator, you switch the 2, then you can get 12 over 7. And if we are to write 12 over 7 here, 12 divided by 7, what do we get, guys? We get 1,71. So 1,71 ohms. Okay. Now, can you compare the two here? What do you notice when you compare the total resistance in the parallel here and also in the series? You'll find that here we have got high resistance. High resistance, what do we mean? It means that our electrons are being opposed, or we are saying the flow of current is being opposed in this case. So the flow of current is highly opposed. So here we are saying here, flow of current is highly opposed. So we're saying there is high resistance. There is high resistance here. So it means that are we going to have more current flowing? Less current is going to flow. Less current. Then here, what are we having? We are having, low resistance. And what are we having when we have got low resistance? It means that we are saying there is little or low opposition to the flow of current or flow of electrons. Then now, what are we going to have now? We're going to have more current flowing. More current flow. So you record more current here. You record more current here than what we see in the on the series. So we can say here current parallel is greater than current that you see in the in the series. That's what we see. Now while we are still on the current here, we talk also of energy. So here, let's say here we have a voltmeter here that that measure the volts here. So we are saying we have got the voltmeter here. The voltmeter is actually measuring the amount of energy that is left in the battery. So now, if I can ask you guys, we have got a series connection and we are not moving more current here. Less current is flowing. Are we going to use more volts here? So let's just say VS, and here this one, let's call it VP. Now, are we going to have what you call more what you call use more volts here or here? So here we're going to use less volts. So we're going to say less volts lost. So, but here we are saying more volts lost. Why? Because we are moving more current here. Because remember, the energy that we're talking about here is used to move electrons. So if we move more electrons, we're going to use also more energy. More volts are being lost. So what are we going to be left in the battery? Are we going to have more energy left or less energy left? So we are saying, what about the reading? What about the reading here? We are going to have a high voltmeter reading. Meaning to say, we are going to be left with more energy here. So what about here? We are going to have what you call low voltmeter reading. So when we talk of series and parallel connection, think of those things. We have got high resistance in series. We have got less current flowing in series. We are losing less volts here. And again, you are going to have high voltmeter reading, meaning to say you are going to be left with more energy in the battery after you connect your battery. But what about also when you are moving the current here? What happened to the brightness of the of the battery? You find here the brightness differs. The brightness, this one here is more bright. This one here is less bright. Why? Because this one takes more energy here, will consume some energy, and whatever is left is going to be used by the second bulb. So this one, you find that bulb will be more brighter than actually the second bulb, because we are saying our current actual direction is from positive to negative. Now, what about this side here? When we're talking of in terms of voltage. Now, voltage that you see here. So voltage on, let's just say here, I'm just gonna put it here. I don't know if you're going to see it. The voltage here and the voltage here are the same. So the energy that you see here, so V1 and V2. So we are saying, just like the current that we have here, that the current is the same throughout here. Here we are also saying V1 or V1 is equals to V2. So the voltage on parallel is equal. So that's what we need to remember. Always remember that here it's equal. So V1 here is equal to actually V2. Okay, I'm gonna put in with another color. This is what you can see. So we are saying there is a V1 there, there is a V2 there. The voltage is the same. Okay, so I think that's all what you need to understand when you are attempting questions. Always remember, guys, the last part of the question that will maybe give you 1 mark, they'll be asking you, will the voltmeter reading what called increase or what called decrease? Again, you must understand when you're moving from parallel. So like, for example, here, if you're giving a switch like this, they'll always give you maybe a switch where we are going to change from what called series to parallel. So if you open the switch, you are on series. So you consider the series condition here. Then if you're closing the switch, you are on parallel, then you consider what you call the parallel condition. Okay, so until next time, guys, thank you so much. Bye-bye.